Rally, rally, everyone. So I think I'm live currently. Okay. Just a minute. Let me the camera a little bit side and unmuted over here. Okay. So I hope I'm audible. Um, Today I have also turned off the subscriber only mode so that things, people don't complain that I haven't been allowing them to comment on live chat. Okay. So should we wait for some time and wait for everyone to join, or should we just start? I think we can wait for some time. Um, Let me just put it on Discord, then I'll start. Okay. And if people over here just write a hi or something like that, okay, so that I know that you guys are over here. And if you can't hear me, you can't hear me. But if you can hear me, just give a thumbs up or something like that. Just that I'm audible or something like that. Okay. Hello, hello, hi. So yeah, you can hear me, right, Pradeep? Or do I? Let me do one thing. Let me put my microphone a little bit closer to me so that it's more audible. Okay. But still, I'll just check with my audio quality. I think it is. I think I'm audible. So yeah. So it is moving on till yellow. So I think yeah, I'm audible. Okay, that's good. Why is it showing only 1.2 accepted in your ID? It's like 3K accepted or for third one, right? Why is it showing only 1.2K accepted in your ID? Oh, this one because I haven't refreshed it now. I haven't refreshed it. Okay, that's the reason they don't automatically refresh things. Okay, so let's start with the first question only. Okay, let's quickly. By the way, how many questions did you guys do? The first question is concatenate non-zero digits and multiply by some one, which is a very simple version of the question. You're given an integer n, form. Nope, nope, no, I didn't solve all four. The last one I couldn't solve. I mean, I, I knew the answer, but I couldn't solve without the help of AI. Okay, so I just prompted AI to do some solutions. But I won't be explaining this. Okay, it was a bit mask kind of thing. Bit mask, and you need SOSDP and mutual exclusion and inclusion. So those things were there, and it's a little bit hard question, I think. But I was also amazed to see that there were a lot of submissions on that. Yeah, only three is good, man. Only three is good. Even I did only three. But seeing so many people who have done D, really like it's really good that so many people knows about bit masking, DP, and inclusion and exclusion stuff. So that's great. So the first question again, okay. Concatenate non-zero digits and multiply by some one. You're given an integer n. Form a new integer by concatenating all the non-zero digits of n in the original order. Let sum be the sum of digits in x. Return an integer representing the value of x into sum. Okay, it's very simple. I won't even show you what the whole thing means, but still, okay, I'll just show you. Let's say you're having a number 1, 2, 0, 5, 0, 0, 6. Okay, so this number you have to convert into first, removing all the zeros, which becomes 1, 2, 5, 6. Okay, and once you get the 1, 2, 5, 6, you have to find the sum of 1, 2, 5, 6. Okay, that is 6 plus 5 plus 2 plus 1, that is I think 13. Okay, so now you have to multiply it with 13. चल रहा है तुम बताओ. So okay, you have to multiply it with 13. So that's it. That's very simple of that question. So if you look into the code, it is very simple. I don't know if I've taken more variables than it was needed or not. Yeah, I've taken more variables. Temp was not needed. I could have directly walked on with n. So while temp greater than 0, d is the current digit, and obviously 10 by is equal to 10. This is a basic thing that you have to do while traversing throughout the whole numbers in a whole digits in a number. And if d is equal to 0, so you know that if it's a 0 digit, you don't consider it only. Neither do you consider it in the sum, neither do you consider it in the resulting thing, this 0 remove resulting thing. Okay, you don't consider in either of them. So you can remove them. Otherwise, you can add it to the sum. And answer, what you can do is you can add d into mat.pow 10 to 10 comma c plus plus to it. So that it means that c is basically the number of digits that a number is currently having. So let's say this is a number and you want to add concatenate this number with a 5 in front of it. So what do you do? 5 into 10 to the power the length of that number, right? That is 4. 1, 2, 3, 4. And then you add that number to it. So that's it. That's very simple of it. I want to know the easier method. For second, I use map to store prefix or prefix even odd. No, why would you need prefix or why would you need a map to store it? I think it's a DP is more than enough for that. But you would need a map to store the XOR at least. Yeah, the XOR you need, but even odd, I don't think you would need a map. I mean, oh, okay. Just a minute. Do you mean that you have stored prefix XOR and prefix even odd diff in the same map? That is what I have also done. Okay. I was thinking earlier. I will also share my observations on that. No need to worry. Okay, so I think this is an easy question. You got it. Let's move on to the second question. The second question is find maximum balanced XOR subarray length. Given an integer array nums, return the length of the longest subarray that has a bitwise XOR of 0 and contains an equal number of even and odd numbers. If no such subarray exists, return 0. A subarray is a contiguous non-empty sequence of elements within an array. Let's take this example. This is a question Pradeep was talking about, okay, by the way, guys. This thing is very irritating. Okay, so let's say you're having this array, okay, and you have to find the longest subarray. I think the longest subarray only. Find the maximum balanced. Yeah, the longest subarray, which is balanced, which means that the number of even is equal to the number of odds in it, and also the XOR of it is also same. Okay. Now see one thing. I think, Pradeep, if you have used map, I think this is the most optimized thing that you can do. This is just a little bit you may think that I'm not optimizing the space, but yeah, that's okay. In CP, you have to try optimizing the time more than the space. Okay. Yes, and this is of these as map dot second, and at the end it is right left. And it's even odd diff is 0 and prefix even odd diff is 0. Okay. And prefix XOR is also 0, then it is I plus 1. I think I get it what you are trying to say. See, what if you know about, so let's first of all, let's not consider that even odd thing is there, okay. Just let's consider that you have to find the longest subarray with XOR is equal to 0. Okay. Now, you know how to do that. You can take a map out of here. Okay, you can take a map, and in that map you can find out the prefix XOR, and you can map it to the positions, correct? That is how we do that. Prefix XOR and the position. That is how we do that in the map. And we, first of all, we put it at 0, the px is 0, and it is at position, let's say -1. That is the position just before 0. Okay, that is -1. Then you XOR this 3 with 0, and it becomes 3, and this is its position 0, correct? Then you XOR 1 with 3, and something happens. Then 3 does again, something happens. So this something goes on happening, okay? Until unless at a one time you will see that actually what you will notice is that 1 or 2 is basically nothing but 3, okay? 1 or 2 is nothing but 3, and 3 or 3 is 0. So if we consider the whole thing, So now it also becomes 3, correct? But the position is different. The position is 0, 1, 2, 3, 4, right? 4. Now since the position is 4, which means that the XOR of all these elements is also 3 and the XOR of just this element is also 3. Which means the XOR of all these elements is nothing but 3 XOR 3, that is 0. Correct? So you can consider that this is a valid thing. Now the point is that now you are also given that you have to find the subarray in such a way that the number of even and odd is same. Okay. So first thing that you have to, that may come to your mind, which is not the correct solution by the way, but it's good that if you're brainstorming something, so it's good to have some things in your mind. The first thing that may come into your mind is that, is it different? Okay, yeah, see, correct. So first of all, you have to think that is it different or not. That is, what if I just do this thing only, that is the subarray, longest subarray, and I don't consider the even odd thing, because you know one thing, that if um, if the XOR of something, okay, if the XOR of some numbers is 0, which means the last digit is also 0, correct? The last digit is also 0. Now, if the last digit is 0, okay, one thing that is just an observation, okay, this is not related to the solution. First of all, I'm just repeating this again. So, if the last digit is 0, it means that at the last digit, there were even number of ones, correct? That means there were even number of odd numbers, correct? This is one observation that you can make. Not necessary, still not, it's not necessary, okay. That is one of the observations. And to balance them, you need some odd numbers also, correct? Now the thing that may come to your mind is that this odd diff, even odd diff difference, okay? That this is the solution. This is not needed. These observations are not needed only. Okay, it may come to your mind just to optimize it. I'm just going through the thought process that you should have during a CP contest. Okay, so it may come to your mind that okay, we can do it like this, but it won't be the case. Okay, you have to move on. And what is the move on thing that you have to do? It's very simple. Okay, it's very simple. Earlier, what you were doing, you were making your mapping px to the position, right? Because your prefix sum was the only constant. Remember, your prefix sum was the only constant. But what if now the number of even and number of odd is also the constant? Okay. So let's say at this position, again one more thing. Okay, at this position, what is the difference between the odd and even? It is 1, right? And at this position, what is the difference between odd and even? 1, 2, 3 odds are there, and 1, 2 evens are there. So that is also 1. Which means that this is having equal number of odd and even, right? We can do that using the prefix of diff minus odd, correct? So that's it. That's it. That's very simple. Pradeep has done the correct one. Okay, that Pradeep has done the. I think this is the most optimized thing that you can have, but I may be wrong also. I am not sure, but I think this is the most optimized. Okay, so you can have it like px instead of mapping it to px pos. What you can do is you can have px. You can have a string basically. What I have also done px, and then you can have something like I have done x. Okay, I have used x because I think x is a unique number. I mean unique alphabet, something that you won't get literally, technically. Okay, so px plus x plus and then the difference of odd and even. Okay, difference of odd and even. And what is the difference of how to calculate the difference of odd and even? It's very simple. If it's a odd, then difference plus plus. If it's a even, difference minus minus. Okay. I think that's it. That's it. Very simple. I'll just show you the code. Just wait a minute. Let me check. The stream is audible, right? I think you guys can hear me, right? I have to see ads for my own video. Let me pull it up. Same, instead of string, I use pair. Works, not an issue. You use pair, you use string, whatever you feel like you use, doesn't matter. Because overall the complexity may vary a little bit, but at the end it doesn't matter. Okay, because it's the big O is same. Simple in simple words. The complexity may be like your code will take 10 milliseconds, my code will take 20 milliseconds, somewhat like that. But overall the complexity is same. So you don't need to worry much about that. Okay, so yeah, I'll just go through the code once. See, initially I'm making it 0x0, okay, and -1, that is the position. And then I have a XOR, that is the prefix XOR, odd, that is the odd even difference, and this is the answer. That is what I will be returning, okay. So I traverse through the whole array and make the XORs all on nums of I. And if I find that this can be optimized, you can use the and 1 is equal to 0. That is also works. That also works. It doesn't matter. So nums I mod 2 is equal to 1, then odd plus plus. So you make odd plus that is that there is an odd extra odd. But if there is an even number, you make odd minus minus, because it is not actually odd minus minus. The number of odd is not decreasing, but the effect of odd is decreasing. Okay, so odd you can think of as effect of odd. Okay, so effect of odd has to be neutralized by the effect of even. So both of them has to be same. That's why we are making it like odd plus plus odd minus one. I think this is somewhat this is called some flag problem. Okay, uh, red not red flag. I don't remember, hoisting flag or somewhat like that problem. If I'm not wrong, I may be wrong. Okay, so now you have to find the key. The key is the XOR and X and odd. Okay, that is how I'm putting them 0x0 somewhat like that. Okay. That is what it's called, right? Correct, great, great. Now, if map contains the key, then it's good enough. Answer is I minus map dot get k. If map doesn't contain the key, then you have to sacrifice it. That is map dot put k comma I and return answer. Okay. So, any doubt on this? Anyone any doubt on this? You guys can say. Otherwise, we can move on to C. Okay. So let's move on to C. Yeah, great. The third question is concatenate non-zero digits and multiply by some two. A little bit modified version of the first question. If you remember the first question, that's very good. The first question was that you have to remove all the zeros in it and multiply it with the sum of the digits in it. Correct. Now there is a twist in the question. Earlier the number was given an int. Remember, the number was in the range of 10 to the power 9, but the number is given now in the form of string. Okay. So now the number it is given in form of string. Okay. You know, I have one penalty on this. You can see this. You know why? Because I forgot to modify the negative numbers. The negative numbers you have to make it like positive, right? Like mod minus, mod plus result, somewhat like that, right? I forgot to do that. I got a flag on. I mean, I got a flag. I had a flag to me. I got a bug on that. Penalty on that. These terms are very CP type of terms. Okay. So you're given a string s of length m consisting of digits, similar to the first question. You're also given a 2D integer arrays query where queries of I is li and r. You have to extract. I got that after 2 runtime errors. Okay, great. For each query, extract the substring, then perform the following. Form a new integer x by concatenating. So whatever you get the substring, 3 penalties. That's that. So whatever you extract from the substring, you get it, and whatever the operation was in the first one, the first question, I had an order today. One of my order is coming. So this one. Okay. So whatever the first question was, it is very similar to that. You have to form a new integer by concatenating all the non-zero elements. Let sum be the sum of digits of n. Then answer is x into sum. Simple. Just now that you are given a substring and you have to perform the operation on that. Which basically means, let's take an example. Let's take this example. I will not remove the C. That's the Leetcode thing. Let it go. Who cares? Okay. So now let's say you have got this. Okay. I'll just cut off this. Ignore this. This is too irritating, man. But it's good. It's good. Actually, it's good that so that if that this plagiarism thing it gets a little bit lower. That's good. So 10203004. Let's have a substring out of it. 0, 7. 0, 1, 2, 3, 4, 5, 6, 7. That is the whole string. So for what the whole string will be? It is 1, 2, 3, 4, and the addition of 1, 2, 3, 4 is 4, 5, 7, 8, 9, 10. So 1, 2, 3, 4 into 10. That is 1, 2, 3, 4, 0. So let's consider something else. Let's consider this 4, 6. Okay. 4, 6. Let's do it. 0, 1, 2, 3, 4. 5, 6. 4, 6 is also not that good. Not worth it. Let's make a test case out of ourselves. Let's consider 4, 7. So that is 34, correct? Into the sum of 34, that is 4, 5, 7. 34 into 7. Okay. 4, 7 is 28, 2. 21, 23, 238. Correct? So this is how the thing should work, and you've got various queries. Now how to do that? It's very simple. Okay, it's not that simple, but yeah, kind of simple. That is obviously one thing that you can understand from here, that since it's a L comma R kind of problem, so you need to have something which is big O and log n type of concept. Okay, because most of the time when it is big O, L comma R, that is queries are there, so it's either prefix question, prefix or, prefix and, prefix or question, or it's a prefix sum question. Okay, prefix also there, goes there also, or it's a segment tree or Fenwick tree, or somewhat like that kind of question, tree kind of question, um, range query kind of question, that is sliding window. But sliding window is a very rare case. In this cases, sliding window is a very rare case. I can think of only one example at this moment, and I don't think anything else. Okay, so yeah, so this is basically a prefix one. Oh yeah, and binary search is also there. Sorry, my mistake. Binary search is also there, but I can't recollect. But I remember that binary search is also a part, because I have done similar question, but I can't recollect what the question was. Okay. So in this question, what you can do is you can, let me just write it, 10203004. 10203004. Now let's say you're having a prefix TP or something like that. Okay. I'll call it TP because I like the name TP, because it's very short. You don't have to write a lot. So this is 1. This is also 1 because we are ignoring zeros. This is 1, 2. This is also 1, 2. This is 1, 2, 3. Same. This is 1, 2, 3, 4. Correct? Now let's look into this. That is the force. Let's say we are talking about the 4, 7 criteria. Okay, 4, 7. So 0, 1, 2, 3, 4, and 7. Now 4, 7 means we have to consider this whole thing. Okay. So how do we know in this 4, 7 how many numbers have been added? That is 3 and 4. First of all, we have to find this 34, right? So how do we know that? This 34, how do we know that? It's basically nothing but remove everything before this. Correct. Sorry. Remove everything before this. You're correct, Pradeep. Remove everything before this and then take this. So that becomes, that is this whole thing minus this is basically what we want. Okay. Let me use a different color. Just for my satisfaction is what we want. Okay. So that is, as Pradeep has said, prefix of right, that is this position, minus prefix of left minus 1, that is this position. Okay. You subtract them. What is this power of 10 comma length difference? I'll tell you. Not an issue. See, 1, 2, 3, 4 minus 12. That is not between 1, right? We don't want 1, 2, 3, 4 minus, we don't want minus 12. We want minus 12, but not the position that I have put it in. We want minus 12 over here. Correct? And these remaining has to be filled with zeros. So how many zeros are there? I have already said 0 is nothing but the length of that you want to replace it with. So what is the difference of this length? 1, 2, 3, 4 and 1, 2. It is 2, right? So that is the length difference into power of 10 to the power length difference. That is 10 to the 2. Okay. So that's how we can do that. So we get 34. Correct? Just a minute. Hello? हाँ हाँ बोलिए हाँ बोलिए हाँ बोलिए हम्म, Yeah. So you get the 34, right? You get the 34. Now that you get the 34, you know how to get the sum of it. The sum of it also you can do a prefix thing. Okay, whatever it is there. So what is the prefix of all this? That is 1 plus 2 plus 3 plus 4. And what is the prefix of this? That is 1 plus 2. So 1 plus 2 plus 3 plus 4 minus 1 plus 2. Correct? So this 1, 2 and 1, 2 gets cancelled out and you get a 34, 3 and 4 only. So that is 7 only. So you can do that also. Correct. And then you can get the 34 into 3 plus 4, that is 7. You get the difference of, you get the product of them and you get the answer of it. Okay. So that's very simple. Correct. So this, it would take you big O n first of all. And secondarily, when you're checking also, it is also taking you big O1 only for every query, right? Because for every query, you're just checking the RL, which is already pre-computed, and you're getting the answer. There's a twist in it. The simple twist is that you can't store it in 1, 2, 3, 4, okay? Because it is given that the number was very large. The number is of length 10 to the 5 digits. So there are 10 to the 5 digits in it, not 10 to the 5. The number is not 10 to the 5. There are 10 to the 5 digits in it. So you can't store it like that. So every digit, every number that you are storing. So basically how do you store? It is like the previous digit into 10 plus the current digit, right? What you can do is you can use a modulo of that directly. because it is given that you have to go for the modulo. Okay, there's a module 10 to the 9 plus 7. So you can do that. I'll just show you the code directly. Class solution, sum and multiply string s in queries. Now n is equal to s dot length, mod is equal to this, dp is equal to this, new long, power is equal to this, digit is equal to this. Okay. So dp is nothing but, I told you, I like naming things dp. Power is to that 10 to the power digit, right? This thing. Now this also needs to be in modulo, correct? So that's the reason we are also putting the power into modulo also, correct? And digit is nothing but the sum of digits, or is it? I think it's the sum of digits only. Yeah, the sum of digits. I really forget things that I'm naming people. I mean naming variables. So power of 0, 10 to the power 0 is basically 1. Then you traverse over the whole n and make the power of 10 to the power 1, 10 to the power 2, 10 to the power 3, 10 to the power 4, 10 to the power 5 till 10 to the power 10 to the power 5. Okay, mod. So you have to modulo them. You got that? Then dp of I is equal to dp of I minus 1, you know, this is a basic relation. And digit of I is equal to digit of I minus 1, because these are prefix. So the previous element will be retained. Retain the previous element. Now if at the current position, the same thing. If it's not a 0, then only we are going to consider. Otherwise, it's not neither going to contribute to the sum, nor it's going to contribute to the dp. That is a string or number, whatever it is. So if it is a not 0, then you know that there's a digit. Okay, so this is basically nothing but the digits. Sorry, not the sum. My mistake. I was also think that this shouldn't be the sum. The sum is over here. Correct. This is the digits. Okay. Why do we need the digit? So that we know the difference in the length of them. Okay. Now you may say that we have the length of it 1, 2, 3, 4, and 1, 2. So we can directly get the length of it. Correct? That is how many numbers are over here and how many numbers are over here. But remember one thing, we are going for modulo. Correct? Since we are going for modulo, it is difficult for us to keep track of the length. Sorry, it is difficult for us to compute the length directly. So we have to keep track of the length. So for length also, we are doing the same prefix thing. Okay? The length of this minus the length of this. So this is a lot, this is a very complex prefix thing, prefix question that you can see. You get it? Sum is also same. Sum of I is equal to sum of I minus 1. I could have done this directly over here also, but you know, like during CP contest, you don't think logically much. So if it is not equal to 0, then sum of I is equal to sum of I plus 1, sum of I plus S of that into mod. Okay? So it's very simple, the same thing, whatever we were doing earlier. We could have joined this on top also where we were doing this, because the same thing was going. Now let's go to the queries, okay? I just told you what is the difference of length. It is digit of R minus digit of L minus 1, right? Minus digit of L minus 1. Just look at this one. Digit of R, don't consider this one. Okay. Just consider this L's part. And why is this there? I'll also tell you. So digit of R minus digit of L minus 1. Now see, if L is equal to 0, so L minus 1 will be an array index out of bound. And since it is array index out of bound, since it is the element before 0, so it's 0 only, correct? The value for it. I didn't think that way. My silly digit calculation will be 10 to the 5, so I stored prefix. Okay. So L R, you get it, length is equal to digit of R, result is equal to dp of R, result into is equal to sum of R. Sorry, not this. Don't consider this first of all. First consider this. Okay. Length minus is equal to digit of L minus 1, right? Digit of R minus digit of L minus 1. That is the length. Result is dp of R minus dp of L minus 1 into power of length. That is this one. This thing that Radeep told us. There is a dp thing. Now result mod is equal to mod. Result into is equal to sum of R minus sum of L minus 1. That is the sum. Right? You multiply it with the sum. You get it? Then again result mod is equal to mod. Correct? Now this is one thing that you have to notice, that is if result is less than 0. Sometimes what happens is when you are modding it, the values get less than 0. The values get in negative. Okay. Now since that the values gets in negative, So in that case, what you have to think about is that if the value is getting negative, then we can have a negative value, right? We have to make it mod. So what you do is you have to add that value to mod. Okay, and you get the answer. So that is simply what we are doing. But if you look at this, if L is equal to, this is basically nothing but whenever there is a L minus 1, since it will be index out of bound, we are not going to consider it. See, L minus 1 is there, so we are not going to consider it. For this dp of r, right, this is there, right? So dp of r minus dp of L minus 1 into, so this is whenever there is a L minus 1, it's 0. Simple. In this case, if L is equal to 0. So result is equal to dp of r. See, result is equal to dp of r. Then result, you may say that why over here I have modded, but why over here we haven't modded? Because result is equal to dp of r and dp is already mod. Okay, so we don't need to mod it twice. Now result into is equal to sum of r minus sum of L minus 1. So what will result that be? Result into sum of r, not L minus 1. Correct? If result is less than, everything else is same. Okay, you get it, you get the answer, and you are done. Any doubt on this? Okay, I'll consider that as a no. Great. Yes, great. Let's move on to the last part of today's contest, rating of questions. I know how to solve D. I mean, I don't know actually, but I now I know. It was a, I think D was a good question, okay, and I don't like if people have done it, so I'm also a little bit confused whether I'm losing my skills or not. But it was a good question, man. I think it needs that respect. Yeah, it was a good question. Because I think I may lose my skills because I have been doing a lot of development these days. So DSA is getting a little bit weaker for me. The first question was easy. Second was find the maximum thing. Huh? This I will consider medium, a good medium, because you have to think of it. But at over here also we can keep it. But no, I think it deserves that medium. It's 6 points only. Is it easy? Which one is 6 points? Last question. Dude, it is bit masking DP. I'm not sure. Yeah, it's 6 points, I know. But I'm not sure. I don't know. I don't think it's easy. For me, I don't think it's easy. But yeah, it may be easy. Like it's basically somewhat similar thoughts I had before coding the problem. But I couldn't like. It's very difficult to do it in during the timestamp. Okay, so it's that way. It's not easy, I think. But um, okay, a good question. Like not a question where you have to think a lot, or rather no, you have to think a lot. But if you have done a similar kind of question earlier, then you don't have to think that much. Okay, because that was a bit masking, there was a DP, there was a SOS, there was a inclusion exclusion principle, there was nothing else. That's it. No, what is the answer? Minimum, maximum, exclusion, exclusion over here, inclusion. I think that's it. That's it. You don't need anything else. C was C was over here, a little bit harder side of medium, and D was hard. Now this things, it can also lie over here also. You can also rate it over here, B, C, D. It depends. It depends on the level of B. Okay. If you want to rate B down to over here, then we can go like B, C, D. Otherwise, B, C, D is. Like I think in today's contest, things were aligned perfectly. This was harder than this, was harder than this, and this was harder than this. So it was aligned perfectly. So that's good. That's good. That's really good. Okay. So that's it from my side. Thank you guys for joining. Second is usually BF is binary. No, BF is breadth first. I don't get it. What is BF? I don't get what is BF, by the way. I thought there is some observation that I'm missing, like even odd makes it simple, but it wasn't. No, it wasn't. It wasn't. Even that is exactly what I was talking about now when I was discussing that things should come into your mind. Yeah, brute force. Correct, correct. Got it. Yeah, second is usually brute force. So things should come into your mind, like we can do it like this, we can do it like that. But at the end, it was a normal one only. But it's good that you're thinking that much. So that's good. Okay, so that's from my side. Thank you guys. We'll see you next weekend on Sunday with another contest. So that's it from my side. Thank you. Bye.